Mr. Clare here from Clare Maths. Today we're going to look at the whole of functions in the Higher Maths 2023 exams. That includes domain and range, composite functions, inverse functions, and graphs of related functions. Let's get started. Okay, completing the square. SQA Higher Maths 2015, paper 2, question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x. Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13, plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1, x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1, x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we'll just complete the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there. SQA Higher Maths 2019, paper 1, question 12. Two functions are defined as f and g. You have to determine f of g of x. So let's do this. Question A, f of g of x, well, that equals f of, well, g of x is 5 minus x. So I'm substituting 5 minus x every time I see an x in f of x. So that is 1 over the square root of 5 minus x. And we're done there. Part B, state the range of values for which f of g of x is undefined. Well, it's undefined when either this is 0, because you can't divide by 0, or when 5 minus x is less than 0, because you can't square root a negative number to get a real value. So we can just write that undefined when Well, 5 minus x has to be less than or equal to 0, otherwise it's undefined. In other words, 5 minus x has to be bigger than 0. So we can then just solve that for x, taking the x over to the other side, you get 5 is less than or equal to x, or to write that in a nicer way, x is greater than or equal to 5. And make sure you've written undefined when, okay? Okay, SQA Higher Maths 2019, Paper 2, Question 8. A function f of x is given by the cube root of x plus 8, and the domain is between 1 and x and 1,000. So x between 1 and 1,000. The inverse functions exists. Find the inverse function. So part A, we have to find the inverse function. So we know that f of x is the cube root of x plus 8. There's a number of ways to find the inverse function, but most of the time, let's just call that y. Y equals the cube root of x plus 8. If I make x the subject, I've found the inverse function. So I'll take 8 over to the other side, I get y minus 8 equals the cube root of x. So I can cube both sides to get y minus 8 cubed would equal x. Do not now write y equals x minus 8 cubed. That gives you a mark off. You now just need to say that, therefore, the inverse function of x is equal to x minus 8 cubed. And we're done there. Part B, state the domain of the inverse function. Okay, so for part B, we know that the domain of f of x is 1 less than or equal to x less than or equal to 1,000. We can work out the range of f of x. If we work out the range of f of x, that is the same as the domain of the inverse function. So the range of f of x, substituting 1 in f of x and substituting 1,000 in f of x. So the range of f of x, so when x equals 1, f of x equals the cube root of 1 plus 8, which is equal to 9. And when x equals 1,000, f of x equals the cube root of 1,000 plus 8. The cube root of 1,000 is 10, so it's 10 plus 8, which is 18. So our range for f of x is between 9 and 18, and therefore straight away we can just say the domain of the inverse function is between 9 and 18. 9 is less than or equal to x is less than or equal to 18, and we're done there. Okay, completing the square. SQA Higher Maths 2015, Paper 2, Question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x. Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13 plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1, x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1, x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we'll just complete the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there. Putting the square, SQA Higher Maths 2016, paper 1, question 12. Functions f and g are defined on a set of real numbers by f is 2x squared minus 4x plus 5. G of x is 3 minus x. Part A, show, given that h of x is f of g of x, show that h of x equals this. So find f of g of x. So f of g of x is equal to, so f of x is 2x squared, so 2 of g of x squared minus 4 of g of x plus 5. So every time I see an x, I put a g of x in, and then I now substitute my g of x. So 2 times 3 minus x all squared minus 4 times 3 minus x plus 5. So we need to expand our 3 minus x squared. So that's 2 times 3 minus x and 3 minus x minus 4 times 3 minus x plus 5. Dealing with all of these brackets, we get 2 times, well, we've got 3 times 3 is 9, minus 3x is minus 6x, and minus times a minus is a plus, so plus x squared. Minus 4 times 3 is minus 12, minus 4 times minus x is plus 4x, and then we've got plus 5 on the end. So that gives me 18, 2 6's is 12x, plus 2x squared, minus 12 plus 4x plus 5. So that equals, we've got 2x squared, and then the x terms, minus 12x plus 4x is minus 8x, and then the number terms, 18 minus 12 is 6, plus 5 is 11. 2x squared minus 8x plus 11, yep, done. Part B, express h of x in the form px plus q squared plus r, so complete the square in other words. So part B, we've got 2x squared minus 8x plus 11, so that's going to equal, well, we take common factor between the first two terms is 2, so that gives me x squared minus 4x, and I've still got the plus 11 hanging on the end, and then we complete the square with the x squared minus 4x, so that's 2 x minus 2 all squared, take away minus 2 squared, plus 11. So that equals 2 x minus 2 squared. 2 2's is 4, so minus 4, and then plus 11. And then expanding the bracket, we get 2 x minus 2 squared. 2 times minus 4 is minus 8, plus 11. That gives us a final answer of 2x minus 2 all squared minus 8 add 11 is plus 3. And we're done there. Okay, composite functions, SQA Higher Maths 2017, paper 1, question 1. F and g are defined as f of x is 5x, g of x is 2 cos x. Evaluate f of g of 0. Okay, there's a couple ways you can do this. You can find f of g of x, or you can work out g of 0 and shove it into f. I'm going to do it by doing f of g of x. So f of g of x is equal to f of 2 cos x. So every time I see an x in f, I put 2 cos x. So that means I've got 5 times 2 cos x, which is 10 cos x. And therefore, f of g of 0, subbing 0 into this, you get 10 times the cos of 0. The cos of 0 is 1, so that means you've got 10 times 1, which is just 10. And we're done there. Find an expression for g of f of x for part B. So g of f of x means every time I see a function in g, I write f of x, which is 5x. So it's g of 5x. And g is 2 cos x, so that's 2 cos 5x. And we're done there. Okay, composite functions, SQA Higher Maths 2018, paper 2, question 6. F and g are given by 3 plus cos x, and g is 2x. X is a member of the real numbers. Find an expression for f of g of x and g of f of x. So part A, 1, f of g of x. That's f of, well, g of x is 2x. So every time I see a x in f of x, I write 2x instead. So that's 3 plus cos 2x. Nice and simple there. And for part 2, g of f of x. So every time I see g in it, I write f of x for x, and f of x is 3 plus cos x. So it's g of 3 plus cos x. G is 2x, so that's 2 times 3 plus cos x. And we can tidy that up a little bit by multiplying the bracket out to get 6 plus 2 cos x, and we're done there. Part B says determine the values for which f of g of x equals g of f of x. So just make them equal to each other. So for part B, we're saying that 3 plus cos 2x equals 6 plus 2 cos x. And we need to solve for x. Everything over at the same side to get cos 2x minus 2 cos x. And then we've got 6. 3 take away 6 is minus 3. That equals 0. So cos 2x we can expand using the start of the formula sheet. We're going to use the 2 cos squared x minus 1 form of it because we've all got causes for everything else. So that gives me 2 cos squared x minus 1. Take away 2 cos x. Take away 3 equals 0. Or 2 cos squared x minus 2 cos x minus 4 equals 0. So 2 is a common factor in this case, so I can just take 2 out as a common factor to get cos squared x minus cos x minus 2 equals 0, and we can then factorise it because it's a quadratic. So it's 2 double brackets. We get cos x and cos x in the first place, 2 and 1, and we've got minus 1 in the middle, so it's minus 2 plus 1, and therefore cos x equals minus 1, or cos x equals 2. So we've got two answers, but cos x equals 2 has no solution, so we can just write that straight away because the maximum and minimum value of cos is 1 and minus 1. So we just need to solve the other one. Cos x equals minus 1, so I can do the inverse cos of 1, which is 0 or 2 pi. But then our cast diagram, cos was negative, so it is pi minus and pi plus in these quadrants. X equals pi minus 0 or pi plus 0, which is pi, or pi minus 2 pi is out with our range, and pi plus 2 pi is clearly out with our range as well, between 0 and 2 pi. So it's just x equal to pi is our solution, and we're done there. Okay, Composite Functions SQA Higher Maths 2019 Paper 1 Question 12. F and G are defined as f of x is 1 over root x and g of x is 5 minus x. Determine an expression for f of g of x. So I've got f of g of x is equal to f of, well, g of x is 5 minus x. So every time I see a x in f, I write 5 minus x. So that's 1 over the square root of 5 minus x. And we're done there. B, state the range of values for which f of g of x is undefined. Well, it's undefined when either this is 0 or negative because I can't square out a negative number. So I write undefined when 5 minus x has to be less than or equal to 0, because it has to be greater than or equal to 0 for this to work, to be able to do it. So I can take the x over to the other side to get 5 is less than or equal to x, or to write that nicer, x is greater than or equal to 5. Make sure you've written undefined when. 5 functions f and g are given by f of x is x squared minus 2, g of x is 3x plus 5. We've defined expressions for f of g of x and g of f of x, and then determine the range of values for which f of g of x is less than g of f of x. Let's get straight into it. Part 1. F of g of x equals, so we've got f of x is x squared minus 2, so we've got g of x squared minus 2, and g of x is 3x plus 5. 3x plus 5 all squared, take away 2. 3 3s are 9x squared, 3 5s is 15, times 2 is 30x. 5 5s is 25, minus 2. So f of g of x equals 9x squared plus 30x plus 23. Part 2. G of f of x. Well, g, I remember, is 3x plus 5, so it's 3f of x plus 5. That's 3 times x squared minus 2 plus 5. So g of f of x is 3x squared minus 6 plus 5. G of f of x, 3x squared minus 1. Determine the range of values for which f of g of x is less than g of f of x. So we're saying f of g is less than g of f. So 9x squared plus 30x plus 23 has to be less than 3x squared, take away 1. Taking the x squareds across, we've got 6x squared plus 30x plus 23 is less than minus 1. So 6x squared plus 30x plus 24 is less than 0. So we've got a quadratic inequality to solve. So let's look for a common factor. 6x squared plus 5x plus 4 is less than 0. So let's look at the roots of x squared plus 5x plus 4. So that factorises to give us x and x. We've got 4 and 1, plus and plus, so roots at x equal minus 1, x equal minus 4. So we can draw a quick graph to show the roots. Minus 1, minus 4. Less than 0 means below the x-axis. Under here, well, it's under here when it's between these two numbers. So our final answer, minus 4, is less than x, which is less than minus 1. Inverse functions. SQA Higher Maths 2015, Paper 1, Question 5. A function g is defined on the real set of numbers by g of x is 6 minus 2x. Determine the inverse function for g. So for part A, there's a few ways you can do this, but I'll write it out the way I do it. 6 minus 2x. I'll just let's say that's y equals 6 minus 2x, and I'll rearrange that to make x the subject. That means taking 2x over to the left, 2x equals 6 minus y, taking the y over to the right. So x is 6 minus y over 2. Splitting that up, that gives me 6 over 2 is 3 minus a half of y. And therefore we can write the inverse function of x is simply 3 minus a half x, or you might prefer the inverse function of x, writing it x first is minus a half x plus 3. Part B, write down an expression for g of the inverse function of x. Well, you should already know that g of the inverse function of x should be x, but let's say you didn't know that, let's do the work for it. So part B, g of the inverse function of x is equal to, well, that's g of minus a half x plus 3. That equals, remember g was 6 minus 2x, so 6 minus 2 times minus a half x plus 3. That gives me 6 minus 2 times minus a half is plus 1x. Minus 2 times 3 is minus 6. 6 minus 6 is 0, so we get x, and there we are. Inverse functions, SQA Higher Maths 2016, paper 1, question 6. F and g are defined in the real set of numbers, and the inverse functions both exist. Part A, if f of x is 3x plus 5, then the inverse function of x. So for part A, I can just write y equals 3x plus 5 and make x the subject. So that means that y minus 5 equals 3x. And therefore y minus 5 over 3 equals x. Don't now be tempted to write y equals x minus 5 over 3 or you'll lose a mark. Just go straight into therefore the inverse function of x equals y becomes x, so x minus 5 over 3. And we're done there. Part B, of g of 2 equals 7, what is the inverse function of g of 7? Right, that sounds a bit strange, but this relies on you knowing what this means. If I put in 2 and I get 7, then that means that if I put in 7 in the inverse, that takes me back to 2. So that just means the inverse of 7 is just 2. There we go. Inverse functions, SQA Higher Maths 2017, paper 1, question 6. The function h is defined as x cubed plus 7. Determine the expression for the inverse function of h. So I can just write y equals x cubed plus 7 and make x the subject. So that means that x cubed is y minus 7. So x is the cube root of y minus 7. And therefore the inverse function of h is equal to the cube root of x minus 7. Again, do not be tempted to write at this stage y equals the cube root of x minus 7 or you'll lose a mark because y is this, is not that. So just watch a little bit of notational thing there. Inverse functions, SQA Higher Maths 2018, paper 1, question 2. G is defined on a set of real numbers by a fifth of x minus 4. Find the inverse function of g. So I can just write y equals a fifth of x minus 4. And make x the subject, so I've got y plus 4 equals 1/5 of x, times on both sides through by 5, I get 5 bracket y plus 4 equals x, and therefore our inverse function of g is equal to 5 bracket x plus 4, or if you prefer, you could expand the bracket to get 5x plus 20. And we're done there. Okay, SQA Higher Maths 2019, paper 2, question 8. A function f of x is given by the cube root of x plus 8, and the domain is between 1 and x and 1,000, so x between 1 and 1,000. The inverse functions exists. Find the inverse function. So part A, we have to find the inverse function, so we know that f of x is the cube root of x plus 8. There's a number of ways to find the inverse function, but most of the time, let's just call that y. Y equals the cube root of x plus 8. If I make x the subject, I've found the inverse function. So I'll take 8 over the other side. I get y minus 8 equals the cube root of x. So I can cube both sides to get y minus 8 cubed would equal x. Do not now write y equals x minus 8 cubed. that gives you a mark of, you now just need to say that therefore the inverse function of x is equal to x minus 8 cubed. And we're done there. Part B, state the domain of the inverse function. Okay, so for part B, we know that the domain of f of x is 1 less than or equal to x less than or equal to 1000. We can work out the range of f of x. If we work out the range of f of x, that is the same as the domain of the inverse function. So the range of f of x, substituting 1 in f of x and substitute 1000 in f of x. So the range of f of x, so when x equals 1, f of x equals the cube root of 1 plus 8, which is equal to 9. And when x equals 1000, f of x equals the cube root of 1000 plus 8. The cube root of 1000 is 10, so it's 10 plus 8, which is 18. So our range for f of x is between 9 and 18, and therefore straight away we can just say the domain of the inverse function is between 9 and 18. 9 is less than or equal to x is less than or equal to 18, and we're done there. SQA Higher Maths 2022 Paper 1 Question 3 was a function h is defined as h of x equals 4 plus a third of x, where x is a member of real numbers, and find the inverse function h to the negative 1x, and this is worth 3 marks. This one is a couple of methods you could use, so I'll go through both methods in case you used an alternative method or prefer an alternative method. So let's look at method 1. Let's call it here method 1. For method 1, to get your first mark, you would say that h of the inverse function of x equals x. You can get a mark for knowing that if you take h of the inverse, the composite function, you always get the answer x. So there's 1 mark there just for writing that down. Then for your second mark, substituting into h, we get 4 plus 1 third, h to the minus 1 of x, and that still equals x. So there's your second mark if you're using composite functions. And then for your third mark, the inverse function, the subject of that. So we'll need to do some work on that first of all. So we've got 1/3 of the inverse function equals x, take away 4, times in 3 by 3 then, the inverse function equals 3 times the whole of x minus 4. And we can leave it in that form to get your final mark, or you could have went on and expanded the brackets, but there's no need to do that. So there's your first method. And let's go through method 2 for the same question. Okay, so method 2 is much more common, I've seen in the high schools used, is where you say that y equals h of x. And that implies that x equals the inverse function of y. In other words, writing y equals the function, if you make x a subject, that gives you the inverse function, okay? So we have got y equals 4 plus a third x in this case, and then we would get a mark for starting to rearrange this. So you could get a mark for doing y minus 4 equals a third x. That's a mark there. Or alternatively, if you prefer to multiply 3 by 3 first, or you could have 3y equals 12 plus x. If that's the way you prefer to go, I would do it the first way, but that's the alternative way. Continuing on with the way that I've done it, that's your first mark, then expressing x, making x a subject. So from here, we're going to times through by 3. So we've got 3y minus 4 equals x, or x equals 3y minus 4. There's your second mark there. And then you have to explicitly state what the inverse function is to get your final mark. So you have to then say that your inverse function of y is equal to 3y minus 4. And so for your final mark, your inverse function of x must be 3x minus 4. And there's our final mark there. Now, just a little notes on like where would the SQA say you can't get marks. Let's look at method 2 to start with since we're on it. We can start off just by writing this and you will get your first mark. If you forgot to write this, we would not take a mark off. Similarly, at mark 3, they would accept h inverse function of x is 3x to the minus 4 without you writing this statement first. So if you just jump straight from here to here, that would be fine also. Also, what you would actually get a mark for if you'd made a mistake is if you'd kept it as y instead of x, we would be quite happy with that and give you the mark anyway, the benefit of a doubt. What we would not allow you to get a mark for, to be very clear, is if you look y equals 3 bracket x minus 4. You have to state it's an inverse function h minus 1. And if you had actually done all this for some reason and not shown any working, not sure why you do that, but if you did in this case, we would actually give you forget the 3 and give you a benefit of the doubt on this question. For method 1, if you go 4 plus a third h to minus 1, if you just jump straight to here, we would give you both marks. We'd be fine with that as well. And of course, again, if you just jump straight to here and just got the answer, we'll give you all 3 marks. So there's your allocations of marks for this question. Method 1 and method 2. Graphs of related functions. SQA Higher Maths 2015, paper 1, question 4. The diagram shows the graph of a function y equals p cos qx plus r. So it's a trig graph. Write down the values of p, q, and r. Okay, so we need to start off with what this function is. The normal cos graph, if you remember, goes between 1 and minus 1, like so, and it goes up to 2 pi. So the number in front is called the amplitude, then the period of the frequency, and then how far it's moved up or down. So immediately we can see that if we look at the q first, we've got 1 up to pi over 2, which means if I was to keep drawing that, I would have 4 up to 2 pi, because pi over 2 is 90 anyway. So I can immediately write down that q equals 4, because I should have 4 of them up to 2 pi. Okay, to get our amplitude, if we just work out the difference between the maximum and minimum, I've got 4 and minus 2 is 6. So to get p, I can just do 4 to minus 2 is 6. Half of that is 3, so I get 3. P is 3. And then for r, well then now I've got p, it's easy. If it was just 3 cos x, it would go up to 3, but it starts at 4, so I've added 1. So r is just equal to 1. And we're done there. We'll write down the values of p, q, and r. Now, what the function is 3 cos 4x plus 1. Logarithmic graphs. SQA Higher Maths 2015, paper 1, question 13. The function f of x is 2 to the x plus 3 is defined on r, the set of real numbers. The graph of equation y equals f of x passes through 1b and cuts the y-axis at q as shown. What is the value of b? Well, it passes through 1b, so I can just sub 1 in. So for part A, we've got f of x is equal to 2 to the x plus 3. So at x equal to 1, we're going to say that f of x equals 2 to the power of 1 plus 3, which is 2 plus 3, which is 5. So just to answer the question, b equals 5. And we're done there. So part B says copy the diagram above, inspect the inverse function, and then write down the coordinates of the images of P and Q. What it means by the images of P and Q is what does P and Q become in the inverse function. So this is an exponential, so the inverse function is a log. So we need to reflect that in the line y equals x. So let's just go ahead and do that. So I've copied the diagram below. So we already know that P is 1b, which we've just worked out is 1, 5. And then let's work out our y-intercept for this graph. So that is when x equals 0. So f of x, which was 2 to the power of x plus 3. That's 2 to the power of 0 plus 3, 1 plus 3 is 4. So we get 0, 4. We need to reflect in the line y equals x, so drawing a y equals x sign. So 0, 4 becomes along 4, 0. And 1, 5 becomes 5, 1. And we've got an exponential curve like so. That's the inverse function of x. So that's part 1 done. And then for part 2, I've already done the work for it. The image of P and Q, we've got 4, 0. And we've got 5, 1. And we're done there. Part C says, R3, 11 lies on the graph of equation y equals f of x. Find the coordinates of the image of R on the graph of equation y equals 4 minus f of x plus 1. So writing down f of x again, f of x, remember, was 2 to the power of x plus 3. And we know that the r lies on this, which is 3, 11. So our new equation is y equals 4 minus f of x plus 1. So what does that mean? Well, let's just take a few notes. In here means we move left by 1. Minus f of x means we reflect in the x-axis. And you can think of this, that's like plus 4, so move up by 4. If it helps, you can rewrite this as minus f of x plus 1, and then add the 4 in the end, and you might be able to see that better. So that means we've got our r, which was 311. So doing the things in the correct order, we apply our reflection, and then we move the left, and then we move up. So our reflection minus f of x plus 1, 311 becomes 3 minus 11, because it drops down underneath. And then that goes to moving left by 1, so 3 becomes 2, so 2 minus 11. And then finally, we need to move up by 4, so we get 2 minus 7 as our final answer. Now, if you're really struggling with that, one way to do it is to go back to the original graph and actually draw it, reflect it, move it to the left, move it up, and note that point moving around. SQA Higher Maths 2016, paper 1, question 15, identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the point 19 to work out our k. X equals 1, y equals 9, so we get 9 equals 1, k times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3. 1 plus 5 is 6. 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5, remember, from our roots, 4 and minus 5. So we're done there. Part B says, for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so D must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, I just write D is greater than 9, and we're done there. Graphs of related functions, SQA Higher Maths 2017, paper 1, question 14. First part was a trig question, and then it moved on to having to draw a graph. So for part A, using our knowledge of trig, we have got root 3 sine x minus cos x. And we have to write it in the form k sine x minus a. So we expand that using the formula sheet. That's k sine x cos a minus k cos x sine a. Okay, so then we just equate the parts to each other. So if we look at the sine x first of all, we've got k sine x cos a, so that means that k cos a equals root 3. So I can just write that, k cos a equals root 3. And similarly, looking at the cos x part, which is over here, we've got minus k sine a equals minus 1. So we can just write k sine a equals 1. K sine a equals 1. So that means that our k, because sine squared x plus cos squared x equals 1, gives us the square root of root 3 squared plus 1 squared. So that is the square root of 3 plus 1, which is the square root of 4, which is 2. So our k equals 2. And then to get your a, so to get our a, remember sine divided by cos is tan, so I can write tan a is equal to the sine, which is 1, over the cos, which is root 3. So that's an exact value for tan a, because we've got a right angle triangle, and if you had 60 here and 30 here, you would have 2, 1 and root 3. So the tan of 30 is 1 over root 3. We need to use a cast diagram just to confirm. So if we look at our cast diagram, we need to check our original functions. Cos was positive, so that would be these two. And sine was positive, that would be these two. So yes, we're in the first quadrant, because we've got 2 ticks in A. So that means I can just say, therefore, A equals 30 degrees. And then our final answer is 2 sine x minus 30 degrees. And we're done there. So for part B, we have to draw the graph, but we've already put it in this form. So we're just going to draw the graph of y equals 2 sine x minus 30. So I know my amplitude is 2, so it's going to go between 2 and minus 2. And minus 30 tells me that it's shifted to the right by 30 degrees. So drawing a nice sketch of that, I can note on the y-axis the points 2 and minus 2. And then we're going to start at 30 degrees because we've shifted along. So we can just start drawing our graph and stop about there because it only goes up to 360. We can note our turning point. So normally it goes along to 90, but shifted to the right by 30 means that this point is 120. So 122. And similarly, this is usually 270 on a sine graph, so an extra 30 makes 300. So we've got 302. The other thing we could do is make sure you go back to 0, so you have to draw what's going to happen here. So it's just going to continue. We could notice where it cuts the y-axis. So it's going to cut the y-axis here, which is when x is 0. If you put 0 into this, you get the sine of minus 30, which is minus a half, times 2 is minus 1. So you could note minus 1 there. And there you go, you've drawn a sketch of the graph. You could tidy that up a little bit if you want. We move on to what I would say is unusual differentiation questions. The first one we're going to look at, just stuff that doesn't come up as often, is this one. A quadratic function is defined on a set of real numbers. This was 2017, paper 1, question 15. Diagram 1 shows the graph of y equals f of x with the turning point at 2, 3. And diagram 2 over here shows the graph of h of x and the turning point is now 7, 6. Okay, let's see what it's asking us to do. Part A. Given that h of x is f of x plus a plus b, write down the values of a and b. So in other words, it's a graph transformation question for part A. So let's have a look to see what's happened. If we look at this point 3, well, let's just look at the turning point. 2, 3, it's clearly moved along to become 7. 2's become 7, it's moved to the right by 5. So if it's moved to the right, then A must be negative. So A is negative 5 because it's moved to the right by 5. And then our B, well, plus B on the end means it's moved, the whole thing's moved up by some number. We started at 3 and we've ended up at 6. 3 plus 3 is 6, so B is simply the number 3, and we're done there. So part B says it is known that the integral between 1 and 3 of f of x is 4. What is the value between 8 and 6 of h of x? Well, an integral means an area, so we know that the area under this bit here is 4. So that means over on this graph, since it's just moved up, this whole area here is also 4, and leaving the extra bit between 6 and 8 is just a rectangle. That is 2 along, and that must be 3 because the graph's moved up by 3. 2 times 3 equals 6, so our integral between 8 and 6 of h of x is just 6 plus 4, which equals 10, and we're done there. Part C says, given that f-1 equals 6, what's h-8? f-1 equals 6, let's just use a different colour pen now. That means that the gradient of the tangent at this point here equals 6, and it's asking us, what is the gradient of the tangent at 8? Well, at 8 on h of x, 8 is this bit here. Now that's, if we imagine looking at this graph instead, that would be this point here. It's a mirror of this, so it's sloping down the way. So it's just minus 6, because it's just the other side of the graph. So h dash of 8 equals minus 6, and we're done there. Solving logarithmic equations, SQA Higher Maths 18, paper 1, question 11. Diagram shows log 3x. On the diagram in the answer book, sketch the curve of equation 1 minus log 3x, and then find the point of intersection between the curves, which will be solved with logarithmic equations. So 1 minus log 3x, the minus part here tells me to reflect in the x-axis, and then the 1 part, which I'll do in another colour here, tells me to then move up by 1. So first of all, reflecting in the x-axis, this point will stay where it is, but this point will jump down here, and that would be at the moment as in point 3 minus 1. But now I have to move up by 1, so this point is going to jump up by 1, so that becomes 1, 1. And you can see this point goes up to 3, 0. So I can just write the number 3 here. Getting rid of my intermediate working, which you could use a rubber if you were doing this by hand. And since it's reflected, it's going to go down and through here. So we can just draw that in, down here, through the way, and there we go. It's a reflection in the x-axis. Okay, part B, determine the exact value of the point of intersection. Simultaneous equations. So for part B, we've got y equals log 3x, but we've also got y equals 1 minus log 3x. So we can say that they are equal to each other and find x. So log 3x equals 1 minus log 3x. So taking the log 3x to the other side, you'll have log 3x plus log 3x. So 2 of them, 2 log 3x equals 1. I can take the 2 up as a power, so I get log 3x squared equals 1. Now I've got it in the form log of something equals a number, so 3 to the power of 1 equals x squared. 3 to the power of 1 equals x squared, and therefore I can find x. X equals 3 to the power of a half, or x equals the square root of 3. And we're done there. Notice it'll only be the positive part of this instead of the negative part, because if x was negative, then you would have log of a negative number, which doesn't exist, so it's just a positive. I can take a note of that. Just positive value, as x has to be greater than 0. So related functions, SQA Higher Maths 2018, paper 2, question 8. So we're starting off with trig and then drawing or stating some values. So for part A, express 2 cos x minus sin x in the form k cos x minus a. We write 2 cos x minus sin x equals, expand the right-hand side using the formula sheet, k cos x cos A plus k sin x sin A. And then we equate our left-hand side and our right-hand side. So looking at the cos x first, the number in front of cos x on the left is 2. What's in front of cos x over here is k in cos A. So we can say that k cos A must equal 2. Doing the same with the sin x. In front of sin x on this side is minus 1. And in front of sin x on this side is k sin A. So we can say k sin A equals minus 1. And remember, to get our k, we just square both numbers and square root them. Why is that? It's because sine squared plus cos squared equals 1. So to get our k, it's the square root of minus 1 squared plus 2 squared, which is the square root of 1 plus 4, which is the square root of 5. So k is root 5. Now to get our a, remember, if we do sine divided by cos, we get tan. So we can immediately write down that tan A equals minus 1 over 2 and solve for A. It's not an exact value, so you get a calculator out to work out the inverse tan of a half. The inverse tan of a half is 26.6 degrees. So using our cast diagram to see what quadrant we're in and the related answer, we need to check it from here, not here. We know that tan A is negative, but cos A is positive. So when cos A is positive, that would be these two quadrants. And sin A is negative. Well, when sin is negative, it's not these two, it is these two. So it's T and C. And therefore, it's in the fourth quadrant because I'm in 2 ticks in the fourth quadrant. So that is 360 minus the angle. So I can say that A equals 360 minus 26.6 degrees, which is 333.4 degrees. Now we've got our A and our K, so we can write down our answer as the square root of 5 times the cos of x minus 333.4 degrees. And we're done there. Part B, hence or otherwise find the minimum value of 6 cos x minus 3 sin A and find the value of x where it occurs between 0 and 360. We know that 2 cos x minus sin x, we've just worked out, is root 5 cos of x minus 333.4. So the minimum value of that function is minus root 5 because that's your amplitude. But this is now 6 minus 3. So in other words, this has been times by 3. So if I just write that underneath, that means we've got 6 cos x degrees minus 3 sin x degrees. Well, since that's been times by 3, I can just write 3 root 5 and the same cos of x minus 333.4 degrees. And therefore, our minimum value is simply the minus 3 root 5 because it goes between 3 root 5 and minus 3 root 5. And we're done there for that. Part 2, the value for which it occurs where 0 is less than or equal to x is less than or equal to 360. So we're looking at this part here, which tells us that the whole graph's been shifted to the right by 333.4 degrees. So if we draw a normal cost graph, you'll be able to see what's happening here. Our normal cost graph would go like this, and it would stop at 360. And the turning point here would be 180, but we're going to shift that to the right by 333.4. Now that's going to take us outside of our range up to 360. So if I extend this back, then this would be minus 180. So that's going to be shifted to the right by 333.4, which is going to take us into between 0 and 360. So if I just use that fact, I can just say that the minimum value occurs at 333.4 minus 180. So minus x would equal minus 180 plus 333.4, which is 153.4 degrees. And we're done there. Graphs of related functions, SQA Higher Maths 2019, paper 1, question 10. The diagram shows the graphs of f and x and kf of x plus a. So f of x is this one here, and kf of x plus a is this one here. State the value of a and find the value of k. So to state the value of a, well, we can't use this because it might have been times by a number, which k clearly has, but if you times nothing by nothing, you get nothing. So we can use the 0 part, and it's just the distance between here. The distance between here is 3, so a is 3. And it's as simple as that. So we know that a is 3. Now we need to find k. So what's happened to f of x? Well, f of x, it should be obvious that it's flipped upside down, so k is negative. And since k is negative, if we just look at this point here, 2 minus, on f of x, 2 minus 1 would become 2, 1. So if I just write 2, 1. But I'm ending up at 5. If I added 3 onto 2, 1, I would get 2, 4. So I must be doubling 1 first. 2 times 1 is 2 to get me to 2, 2. And then adding 5. So that means that k must be minus 2. The minus tells me to flip it upside down. It then gets doubled to go up to 2. Add on 3 is 5. So it's minus 2. And we're done there. (2022) Higher Maths Paper 1 question 10 had this diagram of a cubic function f of x, and it had stationary points at 0, 3 and 4, 0, and with the sketch graph of 2f of x and 1. So what's it asking us here? It's asking us to scale it up by a factor of 2, so times by 2, and then move the graph up by 1. So let's do that on a diagram. We have just drawn this very small here. You can't really see it, but that is the actual question. But it's just so that I can refer to it as we are going. So I've drawn myself a little coordinate grid, and we can start off by looking at the points. So the first point we start off with is 0, 3, and we have got to times it by 2, so 0, 3 becomes 3 times 2 is 6, but then we move it up by 1, so it becomes 7. So our first point is 0, 7, and we get a mark for that. And our second point is we're timesing by 2, but it's along 4 up 0, so 0 times 2 is still 0, but then we add 1, so it goes along 4 up 1, so we can note that point is 4, 1. And the shape of the graph is exactly the same as it was before, so we just carefully draw a nice curve turning here, and we can even label it y equals 2f of x plus 1. So our marks for this, you get 1 mark for a vertical scaling of a factor of 2, which you can see from the graph. By that, we can see that you've times by 2 somehow. You get another mark for adding 1, so we can see you've moved up by 1. You're getting this from the turning points, really. And then transformations applied in the correct order. So that's the final mark for doing it completely correctly, essentially, because you could have thought, well, we need to add 1 first, then times by 2. Now, if you'd done that, 4, 0 would become 4, 1, which would become 4, 2. You would still get a mark for doing both of those things with 4, 2. Similarly, 0, 3 would become 0, 4, which would become 0, 8. It would be obvious you'd added 1 and times by 2, but in the wrong order, so you get 2 out of 3 in that case. Part B says, state the coordinates of the stationary points of the graph at y equals a half x. So let's start off with the original graph again. So we're saying that x is being halved, so what does that mean? It means that we can work out that 0, 3 would turn into 0, 3 still, because of half of 0 or doubling 0 still gives you 0. So 0, 3 is still 0, 3. That makes no difference. Now the only thing that's changing is the x. This one was 4, 0, but I want it to be 4, so if I double 4, I get 8, because a half of 8 is 4. So it must be 8, 0 as well. And you just get a mark for actually working that out with no real working required there, just for stating it. This has been Higher Maths today. We went through the whole of functions for the Higher Maths SQA 2023 exams. That's domain and range, composite functions, inverse functions, and graphs of related functions. Take care, stay safe, and goodbye.